Man, you put me on the spot like that. All right. Hey, everyone. Thanks for tuning in tonight. I'm Jonathan Schrack, and I'm going to talk about DIYing your own SteamVR input or SteamVR input thin client, or as I affectionately call it in the code base, Diet SteamVR. So, this is a case where SteamVR input has its own unique system that's different than what Unity has, and it's different than a lot of other people have. And they have a really nice Unity integration package. However, it's huge. Their package is just massive. Lots of stuff just for the interaction system, just for the input system, and then their code and turns around and generates more code just to manage the inputs that you've defined out. There's nothing inherently wrong with that. However, you might run into some use cases where you just can't handle all that cruft, or you have weird cases where you don't want that. The reason I wrote this for our team is that we already had developed this app using Oculus's backend. And what a lot of people don't know is that about 2 or 3 years ago, in the Oculus integration package that they distribute for Unity, they support SteamVR natively out of the box, and it just works. It'll just seamlessly mask all of the SteamVR like Vive wands, headset, etc. as if they were Oculus. The problem is when Valve released the Knuckles, they broke their drivers. For some reason, the grip inputs and the A button show up as the same input. And they just said, hey, yeah, we're not going to fix that. You guys just need to use the new SteamVR input system and figure it out. And so he said, okay, well, we'd already written all this code, and we just kind of wanted to fix one thing. And so I ended up just deep diving because I discovered that the Oculus integration includes all of the low-level SteamVR, aka OpenVR API. And so you can just call that directly. So tonight we're just going to walk through just a kind of a quick and dirty way you can make your own thin client. And I actually have all the code for tonight up on GitHub, and that will be somewhere, I assume, either in the description or appearing on screen or however. Or you just go to my GitHub account slash JMSchrack, JMSCHRACK, and you should see a repository there called SteamVR Thin Client. So I have this project set up right now. It has Oculus integration imported as well as the SteamVR integration. You technically don't need either, but it helps to have at least one because otherwise, what are you doing? And because both of them have the same file imported. So, like for example, if you have Oculus installed right here, I hope this is showing up on the screen. They have a third-party folder which has the OpenVR API, and this is the entire thing. Or if you have SteamVR, guess what? They have the exact same file right here. It's the same thing. So congratulations, the Oculus and SteamVR basically play with each other at the same time. It's great. So we don't have to do the legwork of getting and wrapping and converting because it's all low-level C code, and this has been converted nice and conveniently for a Unity compatible C#. So let's get this ball rolling. I'm just going to go ahead and create a new folder. I'm just going to call it I'm going to call it Light SteamVR. Be trendy and use an I instead of GHD. There we go. So we're going to go ahead and just create our own kind of. We're going to have to use a mono behavior here to be able to manage the SteamVR input. And part of that's because of SteamVR's paradigm, you need to send an update call once a frame. And so a mono behavior is a logical choice here to tie into that update cycle. So we'll call this, let's call this LSVR, just to the abbreviation, Light SteamVR. Okay. And I'm using VS Code. You can use whatever you want, but I like VS Code. So something to note about the way SteamVR input system works, and hopefully this will show up on screen. The reason why it's a big deal to use the new input system is that they allow you, the game developer, do not have to worry about what buttons are what. You don't have to care. That now becomes a feature that the players have to figure out. I say that as if it's maliciously. No, but it actually is super useful. And so, for example, the player, if I was a player, I open up this screen for whatever game I'm going to play, and I don't know, I'm just going to pick, say, Job Simulator, I think has it updated. And go to edit this binding. And there we go. It shows me these are the controllers I have connected, and I can go through every single button and I can change what they do. And as a game developer, all you have to do, your only responsibility, is just to go through and define a list of actions that your game needs to do. So in this case, let's see. They took the lazy way out and they didn't actually define actions, they just defined buttons. Okay. Let me cut back. Let me steal a better example. Okay, maybe I'll just use my own game. I feel like that was just,
Well, Job Simulator was 2016, so
no excuses. Valve said no excuses, so I would say no excuses in return. So I'm just going to come on. Mint is on here somewhere, and I know we support it because that's what I've been building the last couple days. Let's see. Edit. Yeah. Here we go. So this is actually for the project I was testing out earlier today. Here it says it's complaining me saying, hey, there's actions this game requires that you, the player, have not assigned. And you can see here I just did the basic VR stuff, teleport, grab, do a kickflip. And so the player would then say, all right, well, for grips, I'm going to go here. I'm just going to assign, the grip action. Cool. And I'm just going to make, whatever this thing will be a button. We'll just say this does kickflip or whatever you want. So this frees you, the developer, from having to worry about supporting all these different controller types that come out. That's now on the player. And it's great for the players because for accessibility reasons, they can say, hey, I can't really hit the grip buttons on a controller, or in my case, my trackpad is broken. And so I can reassign all the inputs the game needs to working buttons or for an alternate controller scheme or whatever. And the way this is accomplished, close out of here, close out there. And watch your eyes. I'm gonna bring up Notepad for a second here. So the way this is accomplished is through a actions JSON file. Your project has to have this in the project directory and tell Steamvr this is where it is, and says, hey, this is a list of every action my game needs. And it just says, hey, this is a menu button, teleport option, whatever. Is it a Boolean? Is it a vector, aka joystick? Are they left, right hands? And then the game developer, you can provide a bunch of, hey, here's some pre-set up configurations. And that's all you have to do. And SteamVR will figure out the actual button mapping. So what we're going to do is just make our own thin client to do this quick and dirty, because in my opinion, a thin client or a lightweight client or whatever you want to call it is something where you don't need to have a billion UI options. You just need to have a good solid framework in place that you, the developer, can easily tweak it, enhance it, and make it fit into your existing project. So what I'm going to do here is I'm going to just make, let's say, I'm going to call this but Enums, and you'll see why. Not .com, but .ts. So we're going to have our own namespace. We're going to call it LSVR. What we want to do is that we, as developers, we are inherently lazy, and we want to make our code as easy to read, because typing comments is extra keyboard strokes, and we're not getting paid by keyboard strokes anymore. So what I'm going to do is create some public enums for the type of actions I want my game to have. So kind of like we said earlier, let's say I'm going to do a button enum for all the button kind of actions I'll need. I'm just going to be really lazy. Say menu click, and shoot. Your VR game doesn't have shooting in it. Is it even a VR game anymore? I'm going to do the same thing for, I'm going to make a access as well. So say grip, good old grip access. And with enums, you don't have to assign numbers to them, but we are, and it's going to make our life way easier later. Because remember, as a programmer, you should be inherently lazy. So now you would go through, and we'll say axis 2, axis 3. You could go through for every type that SteamVR supports. And then the sample code I have online, I actually do all the other types as well, with the exception of positional data. But I'm just going to be, excuse me, I don't want to just sit here banging out code on stream. No one, you just guys want to see how it works. So we're going to be quick. So we got buttons, we got axis, great. So the next thing we need to do is that you notice that all of these actions that we have to tell Steam have a kind of a path name to them, like a file system, and they always follow this format of action slash, and they have a set. A set is just a group of actions, and they'll say slash in slash action name. So what we need to do is we need to say somehow tell our code what action sets these belong in. And I'm just going to say this too. Let's say there's a UI set and just say a main set. So what we're going to do here is we're going to make use of a C# trick that allows us to add descriptions to enums, and those descriptions can be pulled in as strings. That way our enum equals a number and a string. So we're going to go using system. I'm gonna cheat. Like I said, I was cheating beforehand when I put this on GitHub. System component model. What this allow is going to do is that now we can use a description tag. So we're just going to call this UI. This will be our UI action set. And we'll call this one main. So what that looks like is that in the JSON file, it's going to be like action slash UI slash in slash menu. Cool. So we'll do the same thing down here. We'll say, hey, this is like this. What is this description attribute tag really for? Don't worry about it. We're just going to use it for what we need it to be. I see a lot of people use description tags and they never use them for what they were supposed to be done. They just use them to store extra strings. So we're going to do the same trick. And to be fair, I stole this trick from Valve. This is actually how they do some of their code snippets, which is I thought was really nice. So all right, we have a nice button enum, we have an access enum. Cool. So we're going to go back to our LSVR file. We'll go to namespace, make sure we are all consistent. Oh, I'm gonna hate that in a bit. Seeing that the LSVR input. You guys don't have to follow along. I have all this code up on GitHub. So my code on GitHub is going to be, yeah, I put it up on GitHub. It's JM Schrack / Steamvr input thin client. If you just go to github.com/JMSCHRACK, you'll find it there. I just created the repo like an hour ago. And it's going to go much more in depth than this because I tried to make it more usable out of the box. But for now, I'm just going to keep this really like high level. That way, this doesn't become like an hour-long video of one guy boringly narrating code. So, all right. So we got this. Cool. So we got our inputs right here. Cool. What we're going to do is we're just going to make some methods because all programmers love static. We hate it, but man, when it's right there and it's easy to use, oh man, it's great. So we're just going to do public static bool get. This is going to be for getting our buttons. So we're going to say, hey, what's it get? It gets a button. And we're going to say lsvr input.button. Whoop. And these are right. Do not like about this? Oh, nope. Gotta let Unity compile for Visual Studio to pick up the updates. Come on, Unity, you can do it. Thank you. All right, there we go. So we're just going to have some kind of instance method, but for now, we'll say return false. And this will allow any of our code elsewhere that's using LSVR input to say lsvr.get button menu, or however we want to do it. However, if you ever done things with VR, you know it's important to get whether it's a left hand or a right hand. So we're going to do another enum controller, do any left and right. And we're going to do the same thing over here. Say, so this way, the rest of my code could be something just like this: lsvr.get, button dot. Got my typing. And we'll say menu. like that, and we'll just say dot controller dot left. So the rest of our code that's not living inside of LSVR, it's very clean and simple to get into. We're just going to say, hey, get this, and we'll have our own variations for get up, get down, etc. I'm not going to go into that tonight, but we're just going to do simple button example, and it'll be nice and sweet. So the catch is like, all right, so far this has all been simple, right? It's like, you're okay. What's Jonathan? Where's the meat of this? I'm like, oh, buddy, you don't want to see it, but here we go. We're going to need to have our own kind of SteamVR init, and this is where things will get a little annoying, as we need to tell SteamVR where our manifest file is, how to get it, and then we have to set up all of our input handles. I'm going to do a couple things first. I'm going to set up some arrays. So if you've never done C# interops before, it's a big, fancy, complicated word that means I'm using C# to talk to C++. So OpenVR is all in C++. And we're going to have to get and retrieve data from that. And what they like to use is what's called ulong or unsigned long. And essentially, they're just going to give us a bunch of ID numbers. So, like, we say, hey, we want input fire. And it's going to say, oh, here you go. Here's a number. And then what we can do is say, hey, Steam, is this button being pressed? And we just tell them the number, and it says, oh, yes or no. So we're just going to do an array just to hold all of our numbers. No one saw that. So, all right. And now, make sure I have my cheat window open. Let's see. Bring this over here. Nope. Wow. Whoa. Hey, David, is my screen still presenting correctly? Because on mine, and it all of a sudden started flashing up a bunch of Chrome notifications. All right, cool. It acted like the input had changed. I was like, wow, Vive, that's new tech. I didn't know you could, crash Google Meet. All right. So one of the things that we have to do is, first off, we have to get the low-level input system. And in SteamVR, the way they expose that is through a system called CVR input. What does the C stand for? I can't tell you. That's a secret. So what we're going to do here is that is located in the valve.vr.openvr. But that's a lot to type out every time I want to use it. So we're just going to say, we're just going to steal a shortcut. We're just going to using remap valve.vr.cvr input to just cvr input as if we have it natively. Because remember, as programmers, we're inherently lazy, and the less typing we can do, the better. So at runtime, the OpenVR API instantiates a couple of systems for us under the hood. CVR input is their system for getting controller inputs out. So we just need to get a reference to it, and it will be good to go. So we're just going to say, hey, CVR input equals, actually, come on, what's going on? Why are you not saving? There we go. I'm going to let Unity compile that real quick. That's fine. That way our autocomplete starts working. All right. Cool. So we're going to say CVR input equals, say, valve.vr.openvr.cvr input. And check my cheat sheet as well. Yep. So in this case, since we already are using it, we should just be able to do this. So that is created for us automatically behind the scenes. We don't have to do anything to instantiate it other than just to call it. It is a getter which will just lazy load it. So now we've done the easy part. Now for everything else. There's a lot of helper methods I'm going to get into, but for now I'm going to go up as if SteamVR worked correctly out of the box. We will set it up, and then I'll go back and add in all the hacks that SteamVR themselves had to do to get it to work. So the next thing I want to do is tell Steamvr, hey, here's the action manifest file. Okay, where's that JSON that has everything in it that it needs to know? So we're just going to do a quick string here. We'll call it our constant for manifest path. Cool. And we'll just say it's at streaming assets slash lsvr slash actions. So if you're new to Unity, the streaming assets folder is a special folder that any file that you put in there is just directly copy pasted after your game is built. So when we put an actions JSON file in there, it's just going to be copy paste. Perfect. So that allows us to just set the file in Unity. And the problem we run into is that SteamVR needs an absolute path. Like it doesn't like this. It wants C/document/ the whole shebang. And again, we could figure that out ourselves. Again, programmers are lazy, and I am especially lazy. So we're just going to use a file info object, and along with a path.combine. Whoop, maybe we won't use a path.combine. Cheat sheet. Where are you? Yeah, that's right. All right, path.combine. And Unity has its own helper method called application.datapath. And this will either return the current folder path of the game, or it'll return the assets folder path if you're running an editor, which is very important. So we're going to say, hey, combine the data path with our manifest path. Cool. A file info out of that. And from file info, we use full name, which gives us the full absolute path. Cool. So cool. We just 3 steps to set up our manifest. Great. It's only going to get downhill from here. And by downhill, I mean like into a fire. So called that up. Now we need to go start getting all the handles. So this is where our trick with naming our inputs with numbers and giving them description tags is going to come in really handy for us. So there's some code here that, again, I stole this one from Valve because I thought it was actually super cool. And this is a really gnarly line of reflection. It's so long. The screen gives me a horizontal scroll bar just to see it all. But what this giant just mess of code does is it just pulls out the description tag. What's that string? This is being done by reflection. And you don't need to know what reflection is, other than that you should never do it, on a frame rate. It's a very slow process, but you do it once to initialize and you're good to go. So what we're going to do here, we go back to our input. And I'm just going to create a public static class, and we'll just call it, let's see, excuse me, our input extensions. And we're just going to create a quick and easy little extension method. We'll say get action set the button enum, and do that. So, oops. They call that I, so now this is I2. All right. So now we make a lot of assumptions here. The reason why our code is going to be really, really small than versus Steam is that we are making a lot of assumptions about how our code is supposed to operate and how it will operate. SteamVR it's over-engineered, however, it'll support any possible scenario. And as developers, we're just like, yeah, we're going to make our own thing, and we're just going to hope that our future selves don't screw it up. Now, as we all know, that's a lie, but hey, that's future Jonathan's problem. Present Jonathan doesn't care right now. So go here, and we're going to say, all right, now we can be able to do handy stuff like, okay, let's just get, whoop, come on, work with me tonight, C#. System.enum.get values. We're going to get all the values of our button. What this will do is this will just give us an array with all of our buttons, and we know that our buttons, the name of them is valid for the JSON, and we can now get the action set that they belong to, and from there we can construct the JSON path we need. So we'll do this. This is supposed to be type of. And we'll say buttons. Let's see. It liked it. Cool. Now we can just do this. Say, hey, for each button in our list of buttons, now have the name of it and the action set. So I'm just going to make a template up here, aka, which is a fancy word for a string that we're going to butcher up later. We're going to call it path template. You'll notice that they always have the exact same format. It's always action slash the action set slash in slash name. Now we can do this. We'll jump back down here, all string.format. We're going to format our path template to have our name, whoop, and to have our action set. There we go. Make sure Unity lets it compile. Oh no, Unity. There we go. What do you not like? Oh, it does not like OpenVR. Let's see, where did I put OpenVR? Line 33. This is on Unity. I literally did this an hour ago, Unity. CVR input is a type, which is not valid. Then we'll call it lowercase CVR, because don't you tell me what I can and cannot do. Anyway, trying to get my autocomplete to work. Blah, blah, blah. All right, there we go. LSVR input button, excellent. Cool, cool, cool. So there we go. So now we have our list of buttons, excellent. And we are going to do we're going to start making our calls to get our handles. So a couple important things to note is that when you're calling into C++, we're having to pass the reference to the variable itself. And normally that is against the law in C#. Low-level variables like numbers are all passed by value, but in C++, they can be passed by reference, and in C#, that's what we're going to have to do. So very important to note that you need to either A, create an array that's local and it's outside your method, or B, create a whole bunch of temporary variables. Because in my experience, even if you try to reuse a variable over and over again, because it's passing by reference, it'll end up overwriting the same variable over and over again, which shouldn't be a problem. That shouldn't happen. However, with mono C#, it's one of those weird quirks that you'll run into. So like I said, I could do an hour talk of here's all the weird gotchas you're going to run into when you're trying to fall down this path. So make a new array, buttons dot length. That's why we have an array for every button handle we need, and we're just going to be accessing that array right inside of it. So, all right. So go back to my cheat sheet. And method we're going to call is called get action handle, and do is that we just feed it. We feed it the JSON path we have, and pass it the reference to the unsigned long index in our array that we want to keep that number in. And what this does is it returns a error enum that Valve has. And so what we can do is if we want to check for errors or anything, we can then just say, hey, if error does not equal 0, we'll just say log it out. Log error, and we'll say error.toString. That's a very C++ style of coding you'll run into, is that when you calling a function, it doesn't return the data you want. Instead, it just returns an error code, and that error code can be 0 for error, no error. And all the data you actually want is going to be passed in and passed out by reference. So, which I know for a lot of people with C#, it's typically the other way around. You typically are just passing, directly return the data you want, and you throw an exception if something happened. However, the reason why you don't do that in game development is that try catch and exception throwing is extremely expensive to happen in the game, and you generally don't want that to happen. It's better just to have it fail silently in the background than it is to you have to throw an exception, because that's what will tank your frame rate. All suddenly you'll be like, why is my game running like a PowerPoint? Well, there you go. You only check your log, you have 1,000 stack traces, but print out one per frame. So now we have our action handle. Cool. We put in an array. Great. And you might be thinking, hey, that's it, right? We're good to go. It's like, no, it gets worse. It's not that bad. Now we have to use the actual action set that I was talking about earlier. This is why it's kind of important that we get that action set value here. So I'm actually going to break this out. Call it action set. So all your inputs are going to be grouped into what's called action sets. And it's important you try to keep those a logical thing. So it might be something like you have an action set that's just for your menus, and versus you have an action set that's for your main game, or maybe you have an action set that's just for driving versus walking around. That way, it allows players to say, hey, when I'm driving, I actually don't want to use the joystick. I want to do whatever. I want to use a foot pedal. Or you, the game developer, can just say, hey, I want to check for all the UI action set buttons right now. I don't actually care about the other stuff. And because what you have to do is that when you tell Steamvr, hey, I need more data, you have to tell it, hey, check the data that belongs in this action set only, which feels a bit counterintuitive because you end up saying, hey, I need to check all the data in every action set possible. But that's where we're just going to assume blindly that, hey, we just want it all anyway, and we don't care how it gets here. This is just supposed to be a lightweight client, and we will fine tune it for our needs later, which will be not here in the stream. So action sets, oof, this is the one that can give you a lot of pain. And it uses a special variable, which is unfortunately on the OpenVR GitHub, where all this stuff is, they don't really document it that well at all. And so I've had to play around with it a lot through trial and error to figure it out. I've found that if you just open up the Valve integration for Unity and just do a file search for // hack, at least every time there's a glitch that they have to like awkwardly fix, they at least put a comment above it that says hack. And it says hack, fix this later. And now comment will be there for 3 years, but hey, at least it's there. So, and we're about to run into that. So one way we could do this is that we could make an enum for all of our action sets, just like we did for all of our buttons, and go through. But again, we're programmers, we're really lazy. So let's just say, hey, action set list. We're just going to grab them on the fly as we move along. What we're going to do is like, hey, we have a set of that. We're just going to keep track of all the set. We're say, hey, does our list already contain this? Contains action set. If it doesn't, add it. And don't be like me and forget to invert this. So we're going to say, hey, if our set list doesn't contain this action set, add it to the list. So there we go. That way, as we are getting all the handles for our buttons, we take note of, hey, what action sets do they belong to? So now we have a list of all the action sets we have to set up. And we're going to do something very similar down here. We're going to say, all right, our action sets array, it's going to be this. Come on, autocomplete. Right. It's going to be action set list dot count. Be that long. And this is where things get a little weird with action sets. And let this on. You can save. Let this save. Let this compile. What the? See, what's a type? You didn't care yesterday when I did this. Anyway, this is where things are going to get a little strange with action sets. Going back to my cheat sheet, and again, my giant cheat sheet, as I call it, is all on GitHub. Action sets have a couple of things that we have to set up. First and foremost is that they have their own handle, and stop. And we just feed it the form of action slash action set, and we tell it where to put the action handle, and it just does it for us. So the question is though, what is UL restricted to device? Well, that would be like left hand or right hand, and you can, when you have to get the input, you have to tell it, hey, give me the jump button, for example. Say, give me a jump button for the left hand versus give me the jump button for the right hand versus give me the jump button for any, meaning either or. And the problem that we kind of run into here is that with the unrestricted device, that's what hand this action set belongs to. And which is kind of strange to me. I'm assuming this was something they were trying to predict in the future, but I have to call update for an action set, and I'll have to call it for both the left hand and the right hand. And then when I get the input, I have to call it for the left hand or the right hand. This allows you the possibility to not check for inputs on a certain hand. Why you would want to not do that, I'm not sure, but hey, the option's there. So the other thing is it has a priority. Priority is 0, 1, 2, 3, anything you say. The bigger the number, the higher the priority. So if there's ever a conflict, so for example, let's say that we have shoot, right? And we said the player put shoot on the trigger, but they also put menu on the trigger. We can say something like, hey, our UI action set has a higher priority right now. And so what will happen is if they pull the trigger and I call, hey, get me the menu button, well, it's going to turn true for the menu, but not for shoot, because this priority is going to override it. And so that's all it does. Basically, if you have multiple inputs that are assigned to the same button on the player's controller, priority just tells Steam which one to use and which ones not to use. So the catch is that we need to, before we can do action sets, I have jumped the gun. We have to get, again, handles for our devices. So we're going to make another array called device handle. And let's see. Yep. Oh yeah, and just to reiterate, I know I mentioned this earlier, but I don't remember if I actually explained my reasoning or not. The reason why we assign numbers to these is that then this is the direct index in the array. So at runtime, when I need to get a handle, my future self-developer is just passing in the enum I want, and the enum just directly translates into an array index. So it's extremely fast, it's extremely easy, and allows you, most importantly of all, to be extremely lazy. So a lazy programmer is a good programmer because it means that you've had to write less code, and the less code you have to write, the less code you have to test, the less code you have to test, the less bugs you run into. So here's where things are going to get weird with the device inputs. So Steam will tell you like, hey, you need to get an input handle for the any controller versus the left controller versus the right controller, which is correct. But there's a bug. And what happens is that I'm looking for my cheat sheet right here, is that you're going to get a handle for the any device. It will not work. It'll be a valid handle. It'll be unique. It'll actually work. Cool. What you're supposed to do is currently is get that handle and just throw it away and just pass in a 0. If you pass, my experience is if you pass in a 0 without getting that handle, it's not going to work. You have to at least try to get it and then tell say, hey, that's nice. I want to put this right here in the garbage where it belongs. So for this case, we have what? Device handle. Again, our code is lightweight because we're making a lot of assumptions, and we're making the assumption that we only care about 3 devices, any left and right. So what we need to do is say, hey, whoop, promise I know how to code. I promise. All right. So what we need to do here is this is where use this line of code. It's just like the action handle, get input source handle, and we have to give it a path. And then we feed it the index we want to feed it to, and that's it. But since we only have 3, we could write a for loop, we could iterate through it, we could match it all, but we have 3 indexes in an array. We're making the assumption that we only ever care about that 3, so we're just going to hard code it for now. Because again, this is supposed to be just quick and lightweight. So for any, they call this unrestricted. And this is 0. Copy, paste, paste. So this is going to be, you might be wondering like, hey, Jonathan, that's really cool that you seem to just know this intrinsically. And I'll be like, yeah, it is really cool, isn't it? But knowing things intrinsically is a fancy way of saying I just know how to control F. So we're just going to go to OpenVR API, and we're going to go to, let's see, where's this one? Do a search hand. Boom, done. Here's all the preset enums or preset constants it's expecting. Or actually just search path or whatever. You'll basically just scroll down the file. I don't know if you can see this. This is just 1,000 lines of all the preset values right here. So you can poke around here. They have a lot of extra stuff in here. Like they have left foot, right foot, shoulders, elbows, knees. Treadmill is listed in here. Gamepad is listed in here. Um, Unfortunately, I've tried to use the gamepad input, which would imply that you could have an Xbox controller plugged in and it would work. And I cannot get it to work for me. I don't have a treadmill to try, but I kind of assume it doesn't work either. So anyway, we'll say, hey, where's my hand left? Yeah, this is the values you want. We could do the same thing with our enum where we use a descriptor tag and then we parse it out. But these values are constant and are relatively static. They haven't changed since Steamvr input system came out a couple years ago. And so we could just directly reference this if we want to, but I'm not. So I won't saw that one either. Boom, handwrite, done. So we say, hey, cool, give me the input for, unrestricted, set it to 0, set hand left to 1, hand right to 2. That's great. And the catch though is that currently to fix things, we have to say, hey, you got that nice handle for unrestricted? Great. Throw it away. It's beautiful and it's gone, just like a unicorn. Excellent. So cool. So now we can start using stuff like, hey, give me the any device. Any device is 0, and it'll get the 0 handle, which is also 0. And we'll do that for this. We'll say, hey, all right, we got our action set. Great. So we're just going to make a quick for loop to loop through these action sets. We'll say, hey, cool. For each string, I'm going to use AS for action set, but that's actually a reserved word. So a set and action set list. Cool. And we're just going to hybridize a for loop and a while loop. Are there better ways to do this? Maybe. Do I care? Not really. So what this would do right now is it would go through, it would create an action set for every set we found and would map it to the any device. Now, if you're like me and you think, hey, well, that's cool. Now that I have any device, I can check for left and right hand, right? Wrong, you can't. It will not work. So what we actually need to do is this. We need to say, hey, make me, for every action set we have, make 3 of them. So we can have 1 for any, 1 for left hand, 1 for right hand. So, I mean, you're going to hear me kind of poke fun of Valve a lot on this kind of stuff. But at the same time, they're trying to predict what people are going to need. And their input system is actually based off of the OpenXR standard. Their argument for, hey, why are we not fixing the knuckles drivers was that hey, well, we already have our new system. It's just like the OpenXR standard, which is going to come out soon. And why do we need to like reinvent the wheel for this? Well, we kind of forget that that's valve time. So soon was 3 years ago, and it still hasn't come out yet. So for valve time, it's on track, which I believe someone can correct me. I think soon in valve time is like 10 years. So I kid. Again, Valve and Oculus and Microsoft and everyone else is on the board of OpenXR, which is part of the Kronos project, and which sounds really cool. And it's just a fancy way to say OpenGL. So we have left, right, center, cool. Action set, great. We need to say, yep. So yeah. So now for every action set we found, we're going to increment through it, create 3 of them, one for any, one for left, one for right. Excellent, excellent, excellent. And that sets us up for success for there. And now we can now actually check for inputs and get buttons and stuff. Except we can't. We have the code in place that will actually initialize it. We actually need to call it, which would, that would be handy. So before we even call it, we have to have a JSON file in place that has the actions. And contrary to what the documentation says, if you don't have a default blank binding file for controller, it will ask the user saying, hey, you need to keybind for this game. It will not let them keybind though. So you have to have at least a blank one in place. Where those are, don't know. But I have a whole set on my example code that will get you up and running on that. But we're just gonna pretend like you already made that. I just made a quick and dirty editor script on my sample code and just spits it out and generates it. It does the exact same thing here. It loops through all the enums that you've set up, generates a JSON file, plops it out. So let's see what this would actually look like in process. Again, I'm keeping this short, sweet, to the point. And by the fact that I'm doing that, we're already at this gigantic, about 100 lines of code. So you'd think this would be shorter and sweeter, but it ain't. So anyway, we now have to actually make code to actually get inputs. And we also have to update stuff. So we're going to say, hey, check my cheat sheet again, because we need to call an update method every frame. And we are right here. Boom. So if you're wondering what I'm deleting all the time here, I actually just, in my sample code, I made an extension method that can be called on any of the error values that Valve returns, and it'll just auto log it if there's a problem. But for now, we don't use it. So we pass an array of every action set we want Steam to update for us. And we also have to do another C++ thing where we pass it the size of the action set. And what does that look? How you do that? Well, this was C++, it's just size of, but since we're in C#, we're going to write out a catastrophe of code and system dot runtime dot interop services partial dot size of capital S size of type of, and it is a action set. So in my sample code, I just saved this out. From what I understand, it's not that actual much of a performance hit to use that, but just do that anyway. So int size of action set. So anyway, now we will actually update every frame, and now we can actually start calling, hey, get left, right, excellent, which we still haven't done yet. This is where I have to give Valve credits, because it could be that like, hey, we'd rather you guys write 300 lines of code to figure out Steamvr input than us have to figure out how to fix our old Knuckles drivers. So credit where credit's due. They're also equally lazy. So we're going to write a nice convenient method, a local method for say, hey, we're getting our button state. We'll say, hey, public bool, call get. I'll just take the exact same parameters. And now You thought this was going to be easy. You're wrong because we have more. Everything's interrupt until proven otherwise. So the way they handle this is that they use a struct called digital action data. And you have to create one. You say, hey, Steam, please give me the button's data for this button handle. And this is where you want to put the data, this is the size of the data. Oh, we want on this device. And in our case, be like, hey, device handle? Yeah, that's why we set our enums correctly. So we can just do this. Boom, device handle array, access it at this enum. Easy. So same thing with our button handles. We have, hey, button handle array, access at, whoop, there we go. Access that this enum, great. And what this actually returns back is a lot of useful data. SteamVR does actually do some stuff under the hood. And we're going to pop into that source code. Not you. This, please. Thank you for trying. So the basic state is B state, which is just a true false value if the button is held down or not. But you also get two other very important things. You get change status. So change is if it happened just this frame. So if you just need to get like get button down versus get button, which is be holding it, you can say, hey, is this true and this true? Or if you need to get button has been released, get button up. Is this false and this true? Now they also pass you an update time. This can be useful for, or sorry, what this is for is this is the last time that this is how much time has elapsed since this button has been checked. And this can be useful for if you're dealing with mine just blanked on me. This can be useful if you're dealing with like lag. For example, if you're trying to say, hey, the user should have been checking for button inputs and we didn't. When was this checked? Like, hey, I need to see if the user let go of a button, but my code mistakenly forgot to check for it. Oh, it's been like 10 seconds since we checked for it. Maybe we just assume that the button was released. Because in theory, if it's checking every frame, it's going to be 10 milliseconds. However, it's one of those things that's such a niche use case that for you might never ever need it, but it's important that it's there. And the other thing is Boolean active, whether this button is active or not. Um, that's useful to see if the player has actually bound it to their controller, because maybe they just didn't have enough buttons and they said, I'm not going to need that one. But then your code could actually adapt and say, all right, the player hasn't key bound, menu click, for example. We'll just use the fire in its place, or however you want to set it. So when we take that data in, we simply just grab it and return, action data dot b state. Now, if you want to be clever, what you could do is just return the action data itself, and then write wrapper methods for get up, get down, etc. But again, this is just a quick little proof of concept sample on top of a quick little proof of concept. So now we can just say, instance reference. I say, hey, instance dot get. We'll just pass in C. So now we have a static way to say, hey, lsvr.get me this button whenever. Of course, if you ran this code right now, it would not work at all. So what we're going to do is we're going to say, hey, we need to do our quick and dirty little singleton setup right here. Say, hey, if instance equals null, we've all done this a million times. Sorry, none of y'all have ever done this before. Don't you know singletons are the devil? They are, but sometimes the devil, Then, so if it's null, we're just going to create our instance real quick. And we'll call our init. Boom, done. And so what we'll do here is say, hey, if instance is null, just return false. So until this has been initialized, we just return false. A few other gotchas I have in here that I've added from just my experience. So you only want to call update action state once a frame, because that's how you tie your game into SteamVR's input update cycle. So if you call it twice, all that data gets lost when these called a second time. So handy way to do this is just keep a record of what was the last frame that was called. It's actually an int, yeah, int. And so then in our update cycle, we say, hey, is the frame count the same? Is the same or less than the last frame that we called this on? Then just bail out early. So, and just as tradition, I always prefer to have some type of initialization variable. I always set the end of my code. Optional, but hey, that's me. Now we have a complete life cycle. So somewhere else, our code can now just call something like lsvr input dot get, and we'll say input button new. And for menu button, we're not going to really care if what controller it came from. And for us, remember, programmers are lazy, so we're just going to say make a default value. Say, hey, if you don't specify, we'll just assume you want any. Done. So now all that code allows you to do very quick and simple stuff like that. So the gotchas that you're going to run into when you try to do this. Setting the manifest is all you should ever have to do to make this work. But it's not going to work right for you. What SteamVR does, it's one thing to keep in mind is that there's the word SteamVR and the word OpenVR. And OpenVR is basically just a single file, and SteamVR is the only implementation of OpenVR. So the OpenVR spec says, yeah, that's all. Setting this manifest is all you have to do to get rolling. Cool. But with SteamVR, which is the only implementation, you do need to take an extra step. And this is where I'm just going to go straight to my cheat sheet, because I ripped this code straight out of their own code. And what they do is that they actually make a call out to SteamVR and pass in what the current processor ID is, what the Unity application ID is, because SteamVR stores an internal database of all the controller configurations that have been set up. So this is like a helper method that they have that I just copy pasted shamelessly, and that's something that you would have to call before you start calling SteamVR methods. So we would have to add this in here, say like very top of our input, say, hey, initialize temporary session, done. And that way you'll actually start having SteamVR work correctly. And so, however, assuming everything's working correctly, you then can just go devices, controller settings, and manage controller bindings. And let's go for, if it wanted to work. Doesn't feel like working anymore. Great. So normally your game or Unity would show up in here. Why it currently isn't doing that? Sometimes SteamVR doesn't want to. So let's just pick that. We'll pick on them. Then you could go in here and you'll see all your inputs here. The players will see all your inputs here. And a very important thing is that you have developer mode enabled in SteamVR. And because then what you can start doing is stuff like, once you have here, show developer output, and it'll just generate a binding file for you. So then you could just copy and paste this and just save it into your project as bindings.vive.json or however you want to call it. And then the actual JSON file at the very bottom, you just have a list of all the bindings you reference. So problems with SteamVR, I can't keybind things for controllers I don't own. It will not let me. It just won't. Like if I have a Vive plugged in, Vive controllers, that will be the only thing I'm allowed to actually create a key binding for. Unless I want to go in and create it by hand, create it manually. Problems with that though is that, as you can see here, it generates a lot of these paths, which are going to be specific to this controller. Like, let's see. Yeah, this is left-hand input system, great. That's on the Vive. Only the Vive controller has that. Well, there's no published list of all the Knuckles inputs. There's no published list for the Windows mixed reality inputs or the Oculus Touch inputs. So SteamVR just it has a lot of great features in it, but it has a lot of missing gaps as well. And this is one of them. So as a developer, you're like, well, that's fine. I'll just use a controller I have, and I'll just only provide that binding, and everyone else can just use whatever controller they have, and that's fine, except it's not going to work. So, for example, here I have a Knuckles controller and a Vive controller. If someone tries to play my game with Windows MR, it's going to pop up and it'll actually pop the overlay up when they launch it and say you need to set controller bindings, but it's going to get to this screen and this is just blank. It just has a loading wheel and it never finishes. Other problems that you might run into with Unity is that sometimes this just doesn't work. There's been so many times where I've actually had to completely just close down SteamVR, close down Unity, restart both, and now it works. Or for some reason this gets stuck on default. Like I'll say, hey, click on custom, and it just will not slide. But other important things, input debugger, when this wants to work, is the most important thing to tell if your code is actually running or not. And let's see if I can show you an example here. Come on. What we're just going to do. Oh, I didn't save. This will run. Okay. What we're going to do is this. Since I have my cheat sheet from earlier, delete this. We're just going to run off my cheat sheet since that compiles. Cool. Going off my cheat sheet. And let's see. Double check that my cheat sheet is set up correctly. That's cool. Device handles, yes, yes, yes. Cool, cool, cool. I saw something earlier that was bugged, and I was like trying to double check it. Yeah, restricting to this, restricting to, yeah. So let's see, access size of, cool, and cool, cool, cool. I copy pasted code and I was like typing out LSVR earlier, and I realized I actually had a typo in this code, and I'm trying to remember where it was, but whatever. Input mode will still work. Oop. I have this debug. It's just a plain text. Oh my gosh, Unity, come on. There we go. This will just show the buttons I'm tracking on left and right side. I'm just using the menu button. I just have a simple keybind, and if I run it, come on, there we go. There we go. Let's see. I get one error in my console. So I log out all the errors it gets. And in this case, it says there's an invalid handle for the menu button. But you'll notice it only ever checked it once, or checked it 4 times in this case. There's a brief window of where SteamVR initializes in Unity, and it'll successfully return handles and everything. However, SteamVR has not connected to your controllers yet, and it will just throw back an invalid handle error, even though it's the one that gave you the handle. So, and this throws this when you're trying to get input, not when you're trying to set up. So it's just something you just kind of have to ignore. So now let's see if this is working. Come on. Put today's Steam, please. Come on. And there we go. Unity. This works. Come on. Today's Steam. And of course, it's not working because I asked it nicely and it heard me talking crap. So what this will normally display, it'll display every action that Steam has loaded from the JSON file, if they've been keybound or not, and it'll actually show you if those buttons are being triggered or not. And as for why it doesn't want to work right now, it's because it heard me talking crap. So unfortunately, like I don't recommend writing your own SteamVR input client unless you have to, just because it's very cantankerous. You're going to run into just as many problems with your own client that are just that SteamVR just didn't feel like working today. Like, why is the input debugger not showing anything from Unity? Well, it's waiting on update from the application, but according to the application, it's working just fine. As a fact, let's see. Let's see. Yep. Nope. Yeah. So on my end, like if I put the headset on and check out the controllers, it actually shows I can view an overlay of where all the key bindings are, and it shows me in VR. I don't have any way of showing that on screen, but it works there. But why is it not working on the desktop client? Just Valve things, unfortunately. But that's it in a nutshell. I know this was probably like drinking through a fire hose. The and I know a lot of it was probably like, here's some very manual, low level code calling, and that's kind of like what a lot of this is. You're not trying to reinvent the wheel here. The reason why, again, like we're not using SteamVR integration is that it has just as many bugs as our own code does, and for us is that we already had a fully working library. We use this setup to integrate. We basically patched Knuckles support back into the Oculus runtime because they use the low level driver calls. Like they're calling buttons directly, and we just changed it so we're now calling actions with them instead. So for us, that's how we got cross-platform capabilities. Um, I'm trying to think of anything else at the top of my head of which problems you run into. When in doubt, just restart Steam, just restart your entire computer. It's from what I can tell, there's just lots of bugs to the Steam VR input system. Um, Other things that, according to the documentation, is possible, but it's not currently possible. Uh, Steam VR input will not let you mix and match controllers. So, for example, the the use case I've seen is that there are people that like to have an Xbox controller plugged in for flight sims. So they'll have their VR controllers in their hands and they'll have an extra set of buttons just on standby for miscellaneous stuff. With Steam VR input, I can set up a gamepad or I can set up the Vive wands or the knuckles. I can't mix and match, even though according to the documentation, you can. But Steam VR does not allow that. Um, Other things to keep in mind too is that the proper way to do this is to use SteamVR input to also grab the positional data of the headset and the positional data of the controllers. However, Unity just does that automatically for you out of the box. So I don't see very many games that actually do that. You can do it. It'll just give you the vector position rotation of everything. You have to convert it into Unity's format because Unity has their XYZ is Y up, Z forward, and I think Steam's out of the box is Y forward and Z down. I think or it's some other format. You just swap a couple of the values around. Um, but again, I'm not here trying to like crap on Steam VR. It's just their implementation is a great idea. It just needs a few more patches to get up to speed. Um, some of that's also I want to say is Unity's fault, just the way the editor works. SteamVR has actually misidentified my application. Like I'm running Unity, and for some reason it thinks that I'm running Job Simulator or something, where it just has a mismatch in its database. Because that's another problem you'll run into is that SteamVR caches every action file you ever give it for an application. And in the case of Unity, it might misidentify your application as something else, especially if it's you have multiple Unity projects. Um, that's another gotcha to worry about. But however, I think overall this is definitely a great step forward. This is the direction we want to go as developers. And so I don't have to worry about it. I can say, hey, does your game support SteamVR? It does. Does it support Vive ones? Not my problem. That's your problem. I can just say, hey, that's on you to figure it out. Unfortunately, the one thing I feel like SteamVR is really missing is that Steam by itself has a controller API. You can have custom controller bindings for every game, and they have a Steam VR input API, and they are not the same. And it really feels like that's a missing step here. That should be linked together. But I don't work at Valve, so I'm not going to tell them how to not document their code and how to not fix bugs. So again, I know I've been saying all night we as developers are lazy, and that's a good point. But however, it's always easy when we're the lazy ones. It's never fun when it's someone else is the lazy ones. So that's it in a nutshell. Again, I know this was just super quick, super fast, but that's why I just posted all the code up on GitHub to play with. Do we want to take questions from anybody, or Steve? I don't know how we're looking on time. I told myself it was going to be a 30-minute presentation, and so I just talked and talked and talked about code for like. But okay. Also, this demo I have on screen right now is actually using the Oculus runtime and using the Oculus runtime, and I'm just patching my own input system on top of it. Because the Oculus runtime, even though Knuckles is broken, it can still get the positional data out of it. So again, why bother fighting with all that mess? But yeah, that's it. Drank from a fire hose, I know. Okay. Panicking mostly, I think. It'll just be me part 2 and be like, by the way, here's how to completely redo everything terribly. Let's see. I think as far as line count goes, my slim implementation, Diet Steamvr, comes in right at under 217 lines of code. I don't include these helper codes because I stole that straight from Steamvr. So versus their input system, which is 20 files, which generate another 20 files. But again, they're trying to do everything. My code makes a lot of assumptions. All right, cool. You're welcome. Again, feel free to shoot me an email or whatever if anyone like falls on across my GitHub and is like, yeah, how is this supposed to work again? Just shoot me an email. I'll happily help out. Cool. Oh yeah, other bugs I ran into is like trying to figure out why my input didn't work, and it turns out that Steamvr undid all my bindings and didn't tell me. That was literally one that happened today. Don't trust Steamvr to remember your bindings at all. Don't trust computers in general.